Okay, so hello everyone, welcome. Can you hear me? Okay, just we're waiting 1 minute for joining all of other participants, then we'll start.
السلام عليكم.
Walaikum assalam. Give you an announcement for our upcoming online training program. Basically, this class will be start from 14 June, and now this registration is the open for the total 7 days complete Google Earth Engine online training on remote sensing and GIS analysis for beginners to advanced level. So this class will be start from that 14 June. If you want to join this online training program, simply contact in this WhatsApp number and also contact with this email. So I already add all of things in the video description. You can simply check it and further you can join in our upcoming live online training program. So basically when you want to join online training program, you can get some benefits such as you can get that course certificate after submitting all of assignment. You can get the all of material, mail slide, PDF. You can get the all of practice code. You can get all of this recorded class. And you can also get the lifetime teaching support. When you face any problem regarding any issue about this online training program, you can face the lifetime free teaching support. So if you want to join this online training program, simply contact in this WhatsApp number and also contact with this email. You can easily get all of those things in the video description. Simply check it and then as soon as possible confirm your seat. Thank you. Okay, so okay, hello everyone, welcome. I hope you can hear me. Okay, so basically today is our third number of class. So after completing this today's session, then we talk about that problem solving class. Okay, so now we'll start our class. Okay, so thank you. Okay, so let me share my screen. Okay, so now can you see my screen? Is it visible? Okay, can you see my screen?
Yes, sir.
Okay, thank you. Okay, so now let's start. Okay, so basically today I talk about that how we can easily calculating any indices from satellite imagery. So any kind of indices, it can be NDWI, it can be EVI, it can be survey, or any kind of indices, how we can easily calculate using Landsat or Sentinel image, both of image, how we can easily apply. I will show you that all of those things. So after completing this topic, I hope you can easily calculate any equation. It can be any kind of equation, EVI equation, NDVI equation, NDWI equation, or any kind of other indices equation. You can easily calculate and also show the result. Okay. Then we talk about that filtering and displaying the satellite images, mainly Sentinel-2 satellite imagery, how we can easily filter, and then after that how we can easily use the Sentinel-2 satellite imagery and monitor the NDWI and NDWI. Right? As well as also talk about that thresholding technique, how we can easily applying the thresholding technique and extract the water body. We also talk about that. And we also talk about the time series chart. Okay, so basically previous class I also discussed about that how we can easily calculate make the time series chart from ready-made data set. Okay, so in this time we talk about the unready-made data set, how we can easily calculate the time series chart from unready-made data set, such as I just make the NDWI map using Landsat and Sentinel. Just I put the equation and calculate the NDWI and also NDWI or any other indices. After that, how we can easily make the time series chart for that. We also talk about that. How we can easily export any shape file from Google Earth Engine, also talk about that, and how to add the gradient legend and also title on your map in Google Earth Engine. We can also add the legend on our map in Google Earth Engine also. I'll also show you that process and how to calculate NDWI from Modis and Landsat data. So let's go on one by one. I also discuss about all of these things. So let me open my slide. Okay, just I open my code. So first of all, I talk about that how we can easily calculating. Suppose just we can filtering the Sentinel-2 satellite imagery. Okay. So for that, simply click on the browse data catalog. Then we can easily get all of satellite imagery. So I want to work for the Sentinel-2 set. Click on the Sentinel, and then just find out the Sentinel-2 image collection. So just I click on here Sentinel-2 multi-spectral instrument. And here you can see we can get that surface reflector and top atmospheric. So just I click on the top atmosphere, and it's very high resolution imagery. And you can get all of information about that. Here you can see we can get that you can see all of aerosol, blue, green, red, and infrared. So basically we can get the 10 meter resolution. You can see this band is the 10 meter, blue band 10 meter, green band 10 meter, red band 10 meter, red is band 20 meter, also near infrared band 10 meter, then short wave infrared 1 band 20 meter. Okay, short wave infrared 2 band is the 20 meter resolution you can get from here. Okay, so now I want to use this imagery, and then I want to filter the image collection for a specific time period. Suppose I want to filter the image collection for 2 time period, dry season and also summer season or wet season, sorry, dry season and rainy season, or summer season or rainy season. 2 time period I want to filter this image collection, and further I want to monitor the water condition for the 2 time period for the dry season as well as also rainy season. What is the condition about that? Okay. Then we try to find out that change detection between these 2 imagery. Okay. So first of all, I need to import this image collection. So just simply copy this snippet and then paste in your code editor. Okay, just I paste, and then you can give any variable name. Suppose I put the name is that Sentinel. Okay, so now this is the variable Sentinel. This variable is stored my full image collection. Okay, so further this image collection I need to filter 2 time period. One is rainy season, another is dry season or summer season. So first of all, I choose my study area. Suppose I need this image for my study area. Suppose Dhaka city. So just I simply import my boundary of Dhaka city boundary shape file. Import. It show the table. Table is a default variable name. We can put any name as a variable. I put the name suppose RY. Okay, done. So now this image, I import my image collection and also import my study area. So now these 2 things I need, I simply import it in my code editor. Then I need to filter the image collection for 2 time period. One is the summer season, another is the rainy season. So for doing these things, I just take a variable. Suppose I put the variable name is that, suppose dry image, and I call this Sentinel because it is stored that full image collection. I simply paste in here. And now I want to need the image collection for my study area in Dhaka city. So for that, I need to use the same function which we already discussed. It's called the filter bounds function. So mainly filter bounds function intersecting with your whole image collection with your study area. This is Dhaka city. In this time, Dhaka city shapefile is stored in the ROI. So just I write here ROI. Okay, done. Not only for that, it's complete only for the higher condition. And now how I need the image, suppose less than 1% cloud cover. So just I put here the filter metadata, and then I need only for this image, which image will be not more than 1% cloud cover. So just I simply click on here, then I can get the image properties and copy the cloud pixel percentage, this property, copy from here and then paste here. Then I put my operator less than and set the value for 1. Okay, so it's complete the how condition. Okay, and now I put here the when I need this image. I need the image for suppose dry season, any month, any year. So just I put here the filter date for when, and then I put here that started and end date, suppose year of 2020, only dry season 1st January from suppose year of 2020 0 April. Okay, I take the April 30. Suppose I put this time period as it considered as a dry season, or you can put any specific time, no problem. So I put here the 1st January from your 30 April. All of images I consider in this time. So now in this time I filter my image collection where, how, and when. Just 3 condition all time. When you filter any satellite imagery, where just first of all where I need the image for the Dhaka city. How I need this image, I need the image less than 1% cloud cover, and when I need this image, I need the image for the dry season. Okay, done. So now I want to create that median composite, or if you want, you can also take only for the specific single image. It's depend on your work. Suppose you can simply print that. Suppose print the dry image, then I can get all of single time period image. So click to the run. Now it show me that all of single time period image. Here I find out that total. I will show you that how many images. 20. Okay, I can get the 20 images for my study area, and this 20 image is the less than 1% cloud cover, and this 20 image is available between this time period. From here, if you need any specific single date image, just simply copy this ID of this image and then paste and work with that. But in this time, I want to create the median composite, which is created from total 20 images middle pixel value and create a one median image. So for that, I simply put here that dot median, and further this image I want to clip with my study area, which is ROI. Okay, so now it's done, and now I want to add the layer. So just put here map.add layer, and I want to visualize this dry image. You can see this variable stored the full things. So just I simply copy, and it's my object name. So just I put here the object. Click to the run. It added the layer, but not focus on my study area. So for that, we already know about that a function. It's called that map.center object. So basically this function center view on a given object. In this time, suppose my given object is the Dhaka city boundary, and Dhaka city is stored in the ROI. So just I put here that ROI and put the zoom level, suppose 10. Click the run. So now it directly view on the center of the Dhaka city, and it also visualize this image look like that. It's the default visualization. So now you can easily add your different types of band combination, and you can also add the different types of visualization. Suppose I want to add the true color composite. So for that, click on here. You can see it show about the setting button or setting properties. So just click on here. So just I click on here, and further I set here. And also you can see the another problem is that scaling. It show that you can see a very long value. So for that, you can see here, you can also check when you want to filter. In this time, you can see the bands that already provide some scale. Okay, and you can see scale is the same all time. Scale value is the same. You can see 0.01 all time is the same value of scaling. So just I also scaling this type of value. So further, I simply copy the one scale value and then multiply with that. Then we can get the proper brands. So after median, we can get the image. So and only we can apply the multiply. Suppose you can see multiply function cannot be applicable for the collection. Okay. Suppose I just put the after the before median, I just put here the multiply. Then it not work, because before median, all of those things just a collection, not the image. Okay. So multiply, add, subtraction, or any kind, this type of function only work for that image. And when I put here the median, then it convert as the image. So that's after the median, I can easily apply the multiply. There is no problem. But if I before the median I put the multiply function in here, then it not work because median, subtract, addition, this type of arithmetic function only work for that image, not collection. Okay? So as for this, I do the same things also in here. After the median, I just put the value which I can get. Yeah. So now click to the run. In this time, we can get the proper range. So now we can simply click on here again and set the pen combination. You can see it show the 6.5. So just I try to add the red, then green, and also blue. So now it show about that stressing 98% for the better visualization. Apply. So now we can get that true color composite. It show the image for dry season of Dhaka city, year of 2020. So you can get this type of imagery. Okay. So, okay, this is our one time period image. So just I simply and further this visualization I want to import in my image. Actually, in this time, if I don't import this visualization in my code editor, then what happened? Suppose without importing this visualization, if I click to the run, you can see this visualization will be gone. Suppose I click to the run, you can see we can get that same default color. It shows as a black color image because I don't import the visualization parameter. So now I just simply import the visual parameter again. So then it will be set with my code. So just I put here again red, then put here that green, put here that blue, and stressing 98% for better looking about this, and then apply. As well as I also need to click on the import. You can see when I click on the import, a new line of code will be added. Okay, it's the visualization parameter. Simply copy this name and paste after the object name of your layer. So in this time, this is my layer. I just paste here. Okay. So now this visualization, mainly red, green, blue, true color composite is set with my code. If in this time I run the code again, there is no problem. Okay. It show the visualization which I already set it. You can see it show about that true color composite. And as well as I also put the layer name. Suppose I put the layer name in this time, it show about the layer 1. I set the layer name, it say suppose dry image, or you can put any name as a layer. So now you can get one image for the dry season. In this time, for the same year, I also take the another image for rainy season. So for doing these things, just simply copy the same code. I simply copy from here, and then I simply change the variable name and also change about the time. So let's go. We try to write the code for rainy season. Okay, just paste here. In this time, I simply change the variable name. Suppose I put this, it's a wait season or wait image. And then I put here that suppose it will be just put here 5 from put here the suppose 4. Okay. So just I put this type of time period for that rainy season or wet season. And further just simply copy and then paste after that. Okay. And then further I remove these things again and run the code. In this time it also added the another layer, which layer stored the image of rainy season. So you can see it show the 2 layer. Okay. So now this image I also set the visualization again and then import the visualization for the rainy season. Same process, simply click on here. And I set the suppose red, green, and blue. Custom, stressing 98%, and further apply. So now it will be apply, and this visualization I also want to import. So just click on the import button and copy this variable name again and paste the object of the layer with image. Just paste here. And then I put the name of the layer. Suppose it's the weight image. Click the one.
Screen is not visible, sir.
This one?
Screen is not visible. Someone has shared their screen.
Oh, yeah. So kindly stop, I think. Yeah. So someone is also, okay. So check. Okay, so
Mohammad Ridwan.
yeah, if I kindly stop the sharing. Yeah. Okay. So now let me share again. Okay, so let me do it again. Okay, now can you see my screen? Is it visible?
Yes, sir. Now it is visible.
Okay.
Yes.
Okay, I'll try again. Okay. So in this time here you can see we take that wait season image again. So for that, what we can do? For that, just we are use the same code. Simply change the time. Simply put the time. Look like that. You can see. Simply put this time 0.5 your 5 1 and also put it at the 10:30 on October 30. Put this time. Okay. Then create the median and then multiply the image and further we also show this image look like that. In this time we got this type of image here. You can see it show about this type of imagery and it also some cloud. You can see this type of white color cloud we can get from here. And if you compare these two images, suppose for dry season and also rainy season or wet season, we can get this type of difference here. You can see. Okay, this is the dry season. It's very neat and clean. Okay, we can get a very clear satellite imagery. For rainy season or wet season, we can get this type of things, cloudy image. You can see there is a lot of cloud that you can get. Okay. So now in this time, mainly when you calculate that indices, cloud is not affect, but cloud is affect when you calculate that land use land cover classification. Okay, then what happened? Then this type of cloudy pixel also mix with our barren land, also mix with our build up area. So then we can face some problem when you want to work for that okay, cloudy image and make the land use land cover classification map. Then we get this type of problem. So that's why I'll for the next class I'll discuss about that how we can easily remove the cloud. Suppose this type of cloud, how we can easily remove and then get very neat and clean imagery about that. So now in this time we discuss about that. We find out the two images. One image is the dry season, another image is the rainy season. So now we try to calculate the NDWI, mainly normalized difference water index. Okay. So and identify for water body for the dry season imagery as well as wet season imagery. We detect the water from the satellite imagery. And then we check, calculate the area, how much water body area increase in the rainy season or your wet season, how much water body area increase for this study area. Okay. So let's go and try to calculate about these things. So first of all, we have to know about the formula about the NDWI. So there are the water index, there are the lot of equation available. So simply search there, suppose NDWI. I simply click on the Google. I just simply search suppose NDWI formula. Then we can easily get the formula. So here you can see it show about the NDWI formula. Look like that. Green minus near infrared divided by green plus near infrared. Another formula is that also you can see about the near minus short wave infrared plus near plus short wave infrared. Not only for simply click on here, you can get a lot of formula for that water extraction. And different types of indices we are also used for water extraction. It can be automatic water extraction or normalized difference water index as well as also modified normalized difference water index MNDWI. So there are a lot of formulas available about that. Okay. So now it's supposed we are just applying this formula green minus near and then we detect the water body from our satellite imagery. So just I copy this formula and then paste here. So now this is my formula. This formula I want to apply for the two images. One is that dry season, another is that rainy season, and then check what happened. Okay. So let's go. We try to apply. So take a variable. Yeah, you can get this. Simply search the Google. You can simply search the Google. Lot of information is available, as well as the Chat GPT. There's a lot of, you can easily get. Simply search on the Google. You can get that lot of things from the indices or other things. Okay. So now in this time we are just use here. Suppose take a variable, and further I suppose I put the variable name is that NDWI. Suppose right. Okay. And now I call the dry season image. So here you can see about that dry season image. So this variable stored the dry season image. Okay, this variable. I simply copy the variable, and then I want to just paste here this variable name. Okay, so this variable stored this dry season image. Okay, and now I just apply a formula. This formula function. This function called the normalized difference. Okay, so this is the function. Okay, normalized difference function. If you want to know a lot of description about that, so just simply search on the docs tab, then we can get that full documentation about that. Click on here. So basically you can see it compute the normalized difference between two band. We can calculate any indices which have only two band. Suppose NDWI, NDWI. So this type of indices only have the two band. Okay, then you can apply this function normalized difference. But some other indices, it can be EVI or SAVI or other types of indices which have more than two band, then what we can do? Further, we have need to put the another approach. But in this time, when you calculate any indices and this indices contains only for the two band, then you can easily use this function, normalized difference function, and compute. Okay, and you can see the normalized difference computed as first minus second divided by first plus second. Okay, suppose in this time first band is the green minus near infrared divided by green plus near infrared. Then you can, it's computed. This function automatically computed. When I put the normalized difference function and then put here the band name, suppose my one band is that green is the B3 for near infrared, for sentinel, and near infrared it's called the B8 for near infrared. Okay, so just put here the B3 green and near infrared. So now this function automatically computed as B3 minus B8 divided by B3 plus B8. Okay, you can see the description about that. It computed the normalized difference between two band, and yeah, it computed first minus second divided by first plus second. In this time my formula is that green minus near plus divided by green plus near. Okay, so this is my formula, and my first band is the green, so that's why I put here the B3. Okay, and second band is the near infrared, that's why I put here the B8. So now this function automatically computed as a B3 minus B8 divided by B3 plus B8 and calculate the NDWI. So let's check the result. So just I add here map dot add layer and call the NDWI dry. Copy and paste here and click the run. So now it added the map of NDWI for the dry season. It looked like as a gray color. So now if you want, you can also add the visualization for detecting the water body. And before that, I take the another variable. Suppose I put the variable name is that NDWI. Suppose wet season or wet. Okay. Then I call the wet season image. So I already make the wet season image. You can see this is my wet season image. I simply copy that and then paste here, and then put the same function. Just simply copy it. Copy and paste here. Okay, and this function only calculate only for the two band. Okay, suppose sometimes when you calculate the EVI or you calculate any equation, which equation including the more than two band or have some constant value. So for that, this normal difference function cannot be worked. So further, we have to use the another approach and calculate the indices. Okay, I'll also show you this today's session also about that. How we can easily calculate any indices, any equation. Okay, so it look like that. So now I want to add the color plated that it look more better. Suppose I just put here I just make a dictionary. So put this type of things, dictionary. I put at the mean, it will be suppose -1. And for the max, suppose for the +1. And put at the plated function and make the some color plated. Suppose red. Then suppose yellow. And then suppose I put at that green. And water body detect as a suppose blue color. And also put the layer name. It's a NDWI. Right. Okay. The same things I also try to add for that wet season. Just simply copy the same code and paste here. Add the another layer for the wet NDWI and paste here. And then further just change the layer name. I put the layer name NDWI suppose wet or rainy season. So now let's try to check about the two layers with their visualization. So now here you can see water cannot detect. So that's why in this time if I just stressing it, suppose just click on here and then stressing this, then we can get the more better visualization. It shows the 0.3. Okay. As well as suppose I to check the another layer, suppose click on here and also stressing this value. This value you can see. It show about that loaded 0.1. So just I change it. Suppose I just put here that 0.5 and not 1. Just stressing. Okay? It's not like that mean and max value. Okay, just for the data visualization, we have put this type of range, then it look more better. So click on the run. Check the result. Okay, we can get this type of result loaded. Okay, so now we can easily trace the water body as a blue color. You can see it show the blue color as a water body. And now we can check the difference between the two imagery. So it show about the wet season or rainy season condition, and it show about the dry season. You can see dry season, there is no water body. Also, there is no water body. So it is very less water body. Just we can get some water body in this lake. Also some here. And but you can see rainy season, it shows a lot of water body pixel. Okay, you can see there's a lot of water body pixel in here. And this is the condition for the rainy season, and this condition for the dry season. You can see dry season, it's very less water body. But when the rainy season, you can get a lot of water body. Okay, so now you can get the two map. One is the dry season NDWI, another is that wet season or rainy season NDWI. So now I want to calculate between that how much water body area increase in the rainy season. Okay, for doing these things in this time we are just applying that thresholding technique, and further we monitor the water body area, how much water body area increasing in here. So in this time for the thresholding technique, for the it's not a fixed. Suppose which pixel value is better work for my study area, this same pixel value is not work for your study area. It's not same. So it's different on your study area or region. Region to region, it will be vary thresholding value. Okay. So for that, how we can easily find out the which value I want to set for extracting the water body from rainy season. For doing these things, we have to just simply check some output. Suppose you can simply click on the inspector tab, and further check some pixel of water. Suppose here you can see, suppose I click on this water body, just click on here, it show me the result. What is the pixel about that? We can easily get it from here. So it show me that you can see negative. Negative means that there is no water. In the dry season, it show that it's a negative pixel. Negative pixel mainly when you can get the negative pixel of NDWI, it means that there is no water. Okay, and you can see the rain in the wet season or rainy season, you find out the water pixel 0.3, same location. You can see about the coordinate also about that. You can see same coordinate. In the dry season, there is no water. How I can understand about there is no water? Basically, when you can find out that index, NDWI index, it show about the negative pixel. It's not a water. It can be barren land, vegetation, or build-up, or any other feature, but it cannot be water. Water can be only for the positive value. High positive value indicating the high water concentration. Low positive value identify about the less water concentration. But negative cannot be watered. Any region, it cannot be watered for negative pixel. So in this time here you can see we can get that 0.3 for the rainy season, but dry season is show about the negative. Okay. Suppose let's check the another pixel. Suppose I just click on here. So now it show that coordinate. For this coordinate, what is the condition you can take? We find out that same. You can see it show the negative 0.2. It means that in the dry season, there is no water body, but in the rainy season, we find out the water body, 0.3. So now from here, we are just set a condition. You can see 0.3. We find out that what is the highest NDWI value in the rainy season. Okay. Suppose this is the map of NDWI map of the rainy season. This is the map. From this map, we calculate what is the maximum pixel value. Okay. What is the maximum pixel value of NDWI? So for doing this calculation, we just calculate the pixel. Which pixel show the maximum NDWI value. Okay. So let's try to find out that. Calculate the value. So in this time, just take a variable. Suppose I put the variable is the max NDWI value. You can put any name. So now I need to calculate the max NDWI value from wet imagery. Wet NDWI. This variable is stored in this map. Okay. So this variable is stored in this map. I simply copy and paste here. And further, I just use a function. This function called the reduce region. Okay. So basically this function, when you calculate any kind of standard deviation, okay, this type of statistical calculation, when you need, we just put here the reduce region. Okay, reduce region function mainly, suppose you have a specific boundary, and from this specific boundary, you want to calculate any specific statistical things, suppose minimum value, maximum value, or average value, standard deviation value. Then we have to use the reduce region function. Okay. So in this time, I want to calculate from this map. So I simply call this map variable and then put it the reduce region. Okay. And now I put all of argument one by one, and then it calculate about that. So just I make a dictionary. So curly bracket start, and also curly bracket in here. And then put one by one all of arguments, simply put in here. First of all, reducer. Reducer, how I can calculate this value? I have to calculate the average, maximum, minimum, or what I need. In this time, I want to calculate that maximum value. So just put here the reducer max. When I need the average value, just put here the mean. When I need the minimum value, just put here the min, mean. Okay. So then put here the maximum, and geometry, it's mainly only for your specific boundary. Okay. So in this time, what is my specific boundary? Dhaka city boundary. I already imported the Dhaka city boundary here as a ROI. So just put here that ROI. Then scale. Scale is the regulation. In this time, it is the 10 meter. And others you want to remove that. So now it computed. Simply print that. Mix NDWI value. And click the run. In this time, it computed what is the maximum NDWI value in the rainy season map or rainy season NDWI. Okay, you can see the object. Just click on here, and we find out that 0.4. Okay, so this is the NDWI maximum value Suppose from the NDWI rainy season map. What is the minimum value you can check? Suppose put at that mean. Click to run. So now it calculates the minimum value of NDWI in the rainy season. Okay, just click on here. You can see it show about the negative 0.6. Negative mainly it's not a water. So now in this time we are just calculate about the water body, and we find out that maximum value of NDWI is that 0.4. Okay, suppose I put at the max, then it calculate the result of maximum NDWI value. We find out that it's the 0.4. So now further, now I want to check. You can see the result. It show about the 0.4. 0.4. Okay. So now you have to find out a water body. It's a permanent water body. Suppose here you can see in the lake of Hatirjil, here we find out the water body pixel in the rainy season or dry season. Okay, so at the same time we can get in here. So in this time I check from the pixel value from here. Suppose I click on here and click on this water body. We can see the result about that 0.2 and also 0.2. The same value you can get in here. Also, suppose I click on here. 0.1, 0.2. Suppose click on it. It's a permanent water body. Okay. So that's why in this time you can see it show about the 0.1 and 0.3. Suppose click on here. So we can get the 0.2. Okay, we can get the for the permanent. If you check the what is the condition for your permanent water body, we find out that it show the 0.2. So in this time, if I set the condition, all of water pixel from rainy season greater than 0.2, it's a your rainy season water. Suppose all of pixel 0.2 greater than 0.2, all of pixel it considered as a wet season water. So if I set it, there is no problem. Suppose in this time we find out that permanent water body show the 0.2. Suppose I click on here again, you can see the result. It show the 0.3 also about that. So also you can simply click on here. Suppose just I open the only for the dry season map. Suppose you can see we can get some water pixel in here. So click on here. We can get 0.2. Okay, you can see 0.2. Suppose also I click this water body. So we set the condition 0.2, all of pixel greater than 0.2 from rainy season water. You can simply check the result. You can see the 0.2. Okay. So for that I set the condition. I just write the code in here one by one. Just take a variable. Suppose I put the variable name is that wet, or just put here the suppose rainy water. You can put any name as a variable. So now I consider the condition NDWI wet season. Suppose I simply call that NDWI wet. NDWI wet greater than 0.2. All of pixel value greater than 0.2 I consider as a rainy water. Not only for that, if this value is less than from dry season water, I also consider it. Suppose I just put here the end function, and then I call the, you can see just simply call this NDWI dry, and this value less than 0.2. So in this time you can see it very important about that. Suppose this technique we are also use also for that flood mapping. Suppose flood water detection or flood inundation mapping, it also used for that. So first of all, you simply check about your permanent water body. Suppose in this time you can get this type of permanent water body, we can find out the 0.2. So now I consider all of rainy season water is pixel is the greater than 0.2. Okay, as well as also from the dry season. Basically dry season, less than 0.2, then it considered about that rainy season water or rainy water. Okay, so this value is not fixed. This value can be vary region to region. So for that you have to check what is the value about that for your specific boundary or specific region. Simply check about that. So in this time I find out that 0.2. So I also can say I can get the 0.2. So if I put the 0.1, then it also mix with my pixel. But if I put the greater than all of pixel of water, which is greater than from 0.2 and less than from 0.2 from dry season NDWI, then we can get that water body. Okay? Extra water body can get from here if I put this condition. So now let's check the result. What the result I can get after doing these things. So for doing this thing, just I take a variable. Suppose I put the variable in is that then suppose water. I put the variable name suppose water max. You can put any variable name. Water max equal. I call this rainy water. These things I want to update. So just put here that update max. And what is my condition? My condition is this condition. I simply copy and paste here. So now let's check the result. So just put here map dot add layer and call this watermarks and click run. So in this time from for this condition which pixel I got, it is stored in this variable. Okay, further I want to update it and store it in this variable. Okay. So now okay, we set the color, then it also more better visualization. I want to set the color. So put at that related, I put the color suppose as a blue color, all of water pixel. So now it create another layer. Okay, so here you can see the result. I just only open this. Yeah. In this time we can get this type of water body area. Can get which is greater than 0.2 from rainy season NWI and less than 0.2 from dry season NWI. Okay, this is the water body. This type of water we can get from here. Now further, I want to calculate the area. And before that, okay, I check the question. Right, so anyone in question, you can write the question. I try to explain. So it's our scale value. Okay, basically, this type of scale value we need to use for reprojected. Okay, reproject the scaling. We have to multiply. We already multiply with the Modis NDWI data. When I talk Modis scale 0.001, we also need to multiply. Okay, same things also for this band. When you want to just multiply with that, so basically it provides you the proper range of that pixel. Okay, when I multiply the 0.001, we find out the proper range. You can easily get that, search the Google or other things. How to check the accuracy using the reference data. Okay, for the accuracy, we have to apply the machine learning. So our 6 number class talk about the machine learning. Then you can get about these things, how can you check the accuracy about that. And then further, I try to calculate But again, those divide. Okay. Okay, negative value is also sure about that. Okay, so you can also share this problem with me, then I'll try to check your study area. So basically this type of thresholding technique, it's vary region to region. Okay, thresholding technique, suppose it only not only for the NDWI, any kinds of indices, any extraction, any specific uh, feature from satellite images, can be vegetation or water body or flood water or anything. Okay, just we are applying thresholding technique, and before thresholding technique, we have to check about that pixel value. Okay? And if then we are just put this type of condition. Okay. Suppose in this time I want to check about that only for the pixel of water which is greater than 0.2 and less than 0.2 from dry season in WI. Then we can get this type of result, this type of conditioning get from here. Okay. But if you change the value, then we also get the different result. So for that, it's thresholding technique. It's very region to region.
But sir, there are ready-made some thresholding techniques like Otsu method, then
Yeah,
H0 method. So can we use it?
yeah. Otsumeru, we can also use it. It's also applicable.
Also, can you show the code, sir?
Okay, so this code is not ready for my side now. So for that class, you can also knock me. I will share this, no problem. So basically, it also
Oh,
used for that. You're also suppose while spinning, you will also use that Otsu method. For that, identify about that type of thresholding technique. Okay, I also try to show that, no problem. It's just one kind of method. Just you can simply check your study area and then check. Suppose in this time I click any water body. Suppose I just click on this water body. You can see about the range. This range cannot be greater than from always. You can see you can get the result greater than 0.25. Okay, which is greater than 0.2, and also get the less than, you can see 0.2. Okay, for the dry season. Suppose I click any other water body. So I just click on here. Same all time you can get the result from wet season greater than 0.2 and less than 0.2 all time. Here you can see the result, you can 0.26, and we can get here that 0.1 which is less than 0.2 from NDWI dry. NDWI even get the 0.1, and we can get that greater than 0.26 result. So all time which condition I set, all of pixel show me this type of result. Also you can see negative 0.47 which is less than 0.2, and 0.25 which is greater than 0.2 from NDWI weight. Okay, so now we calculate the pixel area. Suppose how much area we can get from here. We calculate this type of pixel area from here. So let's